qualitative reasoning with GPS sensor data to estimate infectious disease transmission. So in today's talk, I'm hoping to cover about the relation of the GPS sensor data. So let's can you hear me in the back? Okay, let's get started with these very quick yes or no questions. My father keeps talking about the vulnerable, you're gonna catch a cold. So how many of you gentlemen believes my father is correct? Yeah. What about no? Yeah. Actually, the answer is that my father is totally wrong, because the most of common way to get a cold is for someone who has a cold, sneeze on his hand and then shake yours. So the only way that you can get a cold is for someone to give the germ to you directly, or putting the germ onto something else you might touch. So this is my motivation to study this one. So please keep in mind, infectious disease spread through the human interaction. For instance, physical contact. So there are a lot of the infectious disease, but the kind of such as the communicable disease through the human interaction, such as flu and influenza, and the other one is the vector-borne disease, such as malaria and the West Nile and dengue and so forth. But in this case, I will take the influenza or flu because it is a little bit the simplest way to figure out the spread through the people. So here is the outline that I will cover today. The introduction followed by a concept of state and spatial location variation, SLV as a state, and qualitative trajectory relation, QTRS, and application of QTRS for infectious disease transmission and conclusion. This is the GPS sensor you might be familiar with. Actually, the current smartphone, the iPhone, and the Galaxy has a GPS sensor on it, so you can figure out where you are using the Google Map when you're driving or working or something like that. So through this GPS, we can keep tracking of the individual's movement. So such the individual's movement, I call it the trajectory. So that trajectory can be mapped onto three-dimensional space, which are the longitude and latitude and the time. So let me take this trajectory to explain about it in detail. There are mainly two behaviors, which is the stay and travel. So at the time, for the time duration with the time 0 to time T1 and T2 and T3, obviously the 8 people just stay for one time interval. And these two time intervals, they obviously also travel to the other location, which means they change spatial location. So we can say that GPS sensor data is a consequence of individual's movement, and it is also one of the key components to estimate the physical contact among people. So when I take the trajectory, obviously we can estimate the physical contact. So I will cover about it in a minute, and it also will be helpful for the better disease surveillance and control. So my study is to propose to qualitative trajectory relation to estimate the possible disease transmission using GPS sensor data. So in detail, I would like to discuss about the concept of state for the enriching the current version of BFO, because the current version of BFO 2.0 doesn't have any corresponding entity for the state to referring the situation where the people on the object lays in. So also I would like to specify qualitative trajectory relation or the representation and formalize them and apply the QTRS for the disease transmission domain. So let's take a look at the state. The on object is in the state of the change or not change in the patterns of each dependent, such as the quality, load, and disposition. So for instance, while a people is moving, his or her spatial location change. Obviously, the spatial location can be the longitude and latitude, like the coordinate system, or the distance or velocity and so forth. So the variation of spatial location can be described with the distance and the velocity. In detail, a people who is working, WALK, working, undergoes the change of his and per location in the state of increased the distance and increased or constant velocity. So in this sense, the state denotes the situation in which an independent continuity lays in. So the quality lower disposition might be exactly influenced by the state. So there is a relation between the state and the lower quality and disposition, which call it the shapes in my study. So S shaped Q at T means that the Q is the quality that is consequence or the pattern of the state as at T. As I covered at the beginning, the trajectory is a set of the longitude and latitude and time. So these two representation is obviously use the exactly identical trajectory, but you can, as you can see here, the figure on the right-hand side is more straightforward to figuring out how they travel to other locations for a given time. So the figures on the left-hand side mapped onto the three-dimensional space, and these are mapped onto the two-dimensional space. So the x-axis is standard for the spatial location, which is composed of longitude and latitude. Is more the simple way to see whether the two trajectory at the given specific time. So the object and J just stay for a while and to travel to other location, and the other one is just starting from the movement at spatial location K and the state and travel like this way. So two trajectory are connected at T2. So for the enhancing the granularity, the as known as the spatial scale, temporal scale, let me just take the one-time interval. So the object at the J just stay till the time T1, and the object located at the K at time T move toward to the spatial location J at the T1, so they can interact the spatial location J at time T1. And for the representation, I constraint the number of the trajectory, which is 2, and for more the simple estimation, I just use the one-time interval. So spatial location variation is a state. The SLV is composed of a set of distance, which is a change of spatial location of an object at T1 and T0 and T1. So the distance means refer to this magnitude. So obviously this object doesn't change each spatial location, so the distance is equal to 0. But this one is moved toward to this one. So the distance is the length of this distance. So the length of the distance is also composition of the SLV. So the length of the distance is the derivative of the distance, so which is also obviously the velocity. So for the qualitatively SLVs can be represented with the symbolic value plus or 0. So SLV is represented with the tuple like the distance and function. So all of the possible set of the SLV is plus, 0, and 0 plus, and 0. So in this SLV, the plus refer to the change of distance and the velocity, and 0 refer to the no change of distance and the velocity. So this is my essential idea in this paper. I summarize all of the possible trajectory within 15 cases. The QTR is divided by based on whether an object move or stay or not. So there are mainly 3 cases: 2 stationary trajectory and 1 stationary, and the other one is non-stationary trajectory and 2 non-stationary trajectory. So in detail, this just a stay movement mentioned about the stationary trajectory, and the other thing is non-stationary trajectory for your information. So the first case is 2 stationary trajectory. So these two are doesn't change the spatial location. Obviously, they stay for one time interval. So we can make this kind of the relation through these two representation. So D means the distance of function about using the Euclidean distance, like this kind of the straight the distance. So this means the distance between two trajectories is greater than 0, and the distance at time t1 is also greater than 0, but the distance between this spatial location is exactly the same. So also, the SLV is referring to the state of each trajectory. So the first one means the distance and velocity. So these two doesn't change their spatial location. So obviously they are to the 0. So this one is they just stay together at the specific location. So through these kinds of the relation, we can get to know whether two trajectory connected or not. So this one is obviously non-connected, and this one is connected. The second case is to represent about the one stationary and one non-stationary trajectory. So the trajectory x just stay for one time interval, and another one change their spatial location for one time interval. So at the time 1, the distance between two trajectories is exactly the 0, and for at time t2, the distance between this one is greater than 0. It means here, and since this trajectory change the spatial location, so these two states means the plus. Also, I use this kind of concept for the other situation. So through this S and ST, we can get to know that two possible situation make the connectivity, and the other one two is the non-connectivity. The other one is the one is one non-stationary trajectory, and the other one is stationary trajectory. I got the mistake, but it looks like the other one should be the straight line, like vertically, and the other one like this way, but they couldn't meet at the time t2. So through this representation, we can also estimate these two are the connected and these two the non-connected. So here is the last thing. Two non-stationary trajectory. So only these two cases make us possible to estimate the connectivity. So to sum up the QTRS, there is only 7 cases for the connectivity: TST2, SNST1, SNST3, NNST1, NNST3, TNST2, and TNST5. So let me take these QTRS for applying for the infectious disease transmission. So SEIR model is very widely used to describing the specific stage of the infectious disease at the individual level or population level. But individual level is mentioned about referring to the specific stage of infectious disease, whether it is the susceptible, exposed, the infectious, or recovered. So let me take this SEIR model to define the SEIR state, which is a set of SEIR. So S stands for the stage of susceptible. That means a people is able to be infected. That means they have the probability to get infected. And exposed means refer to the stage of the exposed. That means the people contact with infectious people. So I means the infectious stage, which is a person is able to transmit virus to the others. So R, obviously you can understand about the recovery stage. So the people in the stage of the R, they already have the immunity too. So this means there is any probability to get that virus. So for your better understanding, I prepared the good example probably. Suppose that you can easily understand, keep in mind that this color, each stand for each stage of the SEIR. So suppose that there is, we can, the within the boundary, we can think about any this kind of room. So there are 8 persons, which are the differentiate colored for the each stage. So the red color people, there is 3 susceptible people and 2 exposed people and 1 infectious people and the 2 recovered people. So I assume that within the boundary, people in the stage of infectious have the chance to connect all of the other ones. So in this case, these susceptible people can contact with these infectious people. So for a while, so all of the people's stage transmit to the next one. So these infectious people change to their each stage of the recovered, and the people already contact with this guy change the SEIR's stage into the exposed, and these 2 is already recovered. So this one also got recovered. After that, this guy might be if these 2 guys contact with the susceptible people, I mean the newcomer, probably the newcomer will be the exposed, and these 2 also be recovered, and these 3 guys will be infectious. So also I constrained the only 2 people for making this relation. So I make the all of chance of using the SEIR or for the cases. So the combinatorial relations is all case of the 16. So, but only case of the IDTR, the one of people is susceptible and the other one is in the stage of the infectious, only happen about the transmission. So through this relation, we can get to know the possible transmission cases are only IDTR3 and IDTR9. Using the combinatorial relation between the QTRS and IDTRS, we can get to know the possible spread situation is in total 14 cases like this way. So for the conclusion, the qualitative trajectory relation help to identify the connectivity of the trajectory, and IDTRS that help to identify the possible disease transmission without spatial context. Through the combinatorial relation between the QTRS1 and the IDTR1s, we can easily estimate all possibility of the spread of the infectious disease. But for the limitation, I only constraint the number of the trajectory and the time interval. So for the future research, I would like to do checking the logical correctness by proving the axiom in the last week that Jeon covered about this one. So I will take more time interval and the number of the trajectory. But for the discussion, let's think about the state. Probably you understand, I just come from the outside of the philosophy. So this chance is almost my first time to make the definition of the state. So what I thought at the beginning, what happened this way to predict the process in the future. So when you think about the 8 people just keep moving after for a while, so whether we can think about whether this guy will be moved or just stay for a while. So as I covered the state using the distance and velocity, we can define his stage will be comparing between 2 situations. We can get to know the exact state about the distance around the 10 miles and the velocity, the 10 divided by 1 time. And the other 2 is also the 5 mile and the velocity is 1. And what happened to the other one? So I'm still curious about it. So in this sense, I just think about the quality and lower disposition at the specific time is consequence patterns of the state at the time, and state in an entity to shape the quality, lower, and disposition. John.
If I understand your formalism, the way you captured the trajectories earlier, and let me ask you. It's okay. It's possible for two entities to have the same trajectory, to share the same trajectory. That seems plausible.
Oh yeah.
How do you determine just with plus and zero for velocity what the direction? So I'm imagining an entity moving this way with the same velocity or same trajectory as an object moving this way.
Actually, this representation is I forgot to mention about it. This y-axis is time, and this axis is spatial location. So also using calculating the distance, we can get to know the orientation or the distance between two objects. So I mean possible. Yeah.
So I'm trying to understand what a state is and what kind of work it's doing for you, and in order to help you figure out how to define it and think about it. So can you tell me a little bit more about state?
Yes. This is a tricky one. So.
What do you want to say about states and what kind of information goes into making sense of a state? I think you had some earlier slides on this too.
Let me show the. This one. When it comes to process, we don't know what's going on in general sense of the geography, statistics one, but ontology will be helpful to specify what is going on, you know. So in order to, while using the state, probably we can know the exact disposition about what I mentioned before, like the people is willing to move or stay. So I just thought about this kind of the entity will be determined by the state.
So your first definition there, the state denotes. I mean, denoting I think holds between some kind of information and some state of affairs or object. And so a state is an information.
Oh, originally the state comes from physics, theory of the physics. So in the field of the physics, the state is to a situation about the particle or the object where they occupied in the spatial location or the time. So I'm still curious and got stuck to define making this definition. So,
John, did you have a treatment of state in your thermodynamic?
Yeah, it was restricted just to equilibrium in thermodynamic context.
I don't know if that would be helpful.
I'm not sure it would be helpful for this. It's specifically designed not to move or change.
Let's talk about it in the break. Yeah, that would be helpful for me.
So I would like to have a definition of state which corresponds to at least a large subset of ordinary uses of state, and which overlaps with a large subset of scientists' uses of state. And I've thought about this problem for a long time. So state is very close to quality. And it seems to be related very often to cases where we have an individual which has a certain quality and then has a different quality and then has another different quality, but we say that they are in the same state through the whole course of that time. So a state of pregnancy, for instance. A state of pregnancy would be a state of having some kind of defined quality of having a fetus or having an embryo or having an almost born infant inside your womb, roughly speaking. So the state is more general than the quality. It's a range. It's being in a certain range of quality.
In the sense, the SEIR, the state will be quite similar.
So I think that something like that, it's very hard to define carefully, but something like that would apply to SEIR. But we do not use the word state in regard to people's spatial locations. So we don't say that you are in the state of being in Buffalo, or you are in the state of being behind the podium.
Yeah.
And so, and I don't think that in physics people use the word state to refer to the state of being at a certain spatial location, or the state of being at Wednesday. So I don't like the way in which you're using state for the spatial and temporal case, purely for reasons of strategy. So if we're going to get state accepted in BFO and we define it in a way which is different from any ordinary language usage, then no one will ever use BFO state. So I think a tentative or a tempting view of state would define a state as follows: X is in a state S means there is a certain range of qualities. For instance, the range of all color qualities, and there is a sub-range of that range, which is called, for instance, being dark-colored, or even then, it's not. We don't say you're being in a state of being dark-colored. But in the case of pregnancy, I think we are talking about a range like that. In the case of susceptibility to infection, we're talking about a range like that. So I still think the range idea is attractive, but I don't know how to define it in completely rigorous terms. And we can't add a term to BFO, and you can't give a talk using a term until you have a good definition.
Thank you.